Welcome to the computer graphics practice video, and the task is Lindenmayer Tree. So Lindenmayer systems or L systems are used for all sorts of different procedural generation algorithms, and I recommend you to also check out this book, The Algorithmic Beauty of Plants. It's gonna take some time to load here, but basically this is by Lindenmayer and his friend. I think it was published after Lindenmayer's death. It talks about different ways you can construct those systems. What are rewriting systems? What are formal grammars, context-sensitive stuff, and the turtle interpretation of the words generated by the system, and all sorts of patterns you can make with L systems, and all sorts of things like trees and these things and lots of different interesting pictures and math. So I recommend you to browse through it. It has cool images and algorithms and patterns of nature and stuff in it. But in this task, we'll be implementing a zero context stochastic system. And the task says that there should be this rule, like this, three rules, or like one rule depends on how you read this. But you can also implement your own rules. So if you don't like this, then feel free to come up with your own ideas. Okay, but let's open the base code, and if you run this in a browser, then currently it's white. And so let's look at the code. Now we'll be using this 2D context again on the canvas, because the trees will be 2D trees. And an L system is a parallel rewriting system where we iterate over the whole string, like some amount of iterations, and we rewrite or substitute all the letters that we can in one go. So we apply as many rules as possible. So this is why we have here this iterate system function. It takes the axiom, so the starting word, and it says how many iterations you want to do on this axiom. And then it draws the result of this system, so this will be a word to this coordinate. Now this is the debug call, and when everything seems to work, then you can comment in these calls, and then these should generate you this picture. Okay, but don't start with this, because then you're probably going to, if you have bugs, then it will be really difficult to debug it, because it does so many different things at once, and then you can see what's happening. It's better to start with just one simple tree, one simple goal, one iteration, and even there is only one rule here currently. So yeah, rules. This is the left side, and this will be an array of the right sides. So as you remember from the lectures, stochastic rules, the probabilities need to sum up to 1 for the same rules with the same left side. Okay, and this iterate system should iterate over the system. Currently it does just one rewrite. And we also output the final system to the log, so I guess we can even currently see this will be the word that needs to be drawn as a tree on the screen currently. And what do we have? We started from A, and this will be that result, because the rewrite system function is also not finished. It currently just assigns the first matching rule. So that is the first matching rule, and so that's assigned. Okay, this function is interesting. It replaces rule parameters, and there's probably a better way to do this. But those rotation parameters, so the letters are that A is a pod where we will create a new part of the tree in the next iteration, F is this one segment of branch or trunk that's already done, it's already fixed that it should be there. And then we have rotation, so this parameterized symbol. Rotate left by angle A, rotate right by angle A, so minus and plus, although, yeah, so left it's like counterclockwise, I guess. So here, what this function here does, it splits the whole thing by these brackets A, and here you should go through the splits and put random angles between them using this random variable. So if you find out a better way to replace replace all with some different values in a string, then feel free to do it differently. And then we come to this draw system function. So this is what handles the turtle graphics. So probably you have already seen turtle graphics in some programming course, but the idea is that you have some sort of a turtle, I don't know, and this turtle has a pencil. Where was it? On its tail somewhere. There's a pencil, or maybe it's this one isn't all that nice. I don't know. He has it on his hand, so he's drawing stuff. And basically, the turtle can move forward, can turn around at one point, left or right, or maybe via some angle, then again move forward, and turn again, move forward, turn somewhere else, move, and so on. And here he can also revert back to some previous state. For example, here, and continue moving forward. Or come back here, turn, and continue moving forward. And so this kind of logic draws this kind of a shape. So I don't know, this is where the turtle graphics idea comes from, of some turtle with a pen. But so a turtle has a position, has a direction, has the line thickness, and basically the length of the segment he needs to draw. So how far he's supposed to go. We'll also be using a stack here, so this is for saving and loading those states, coming back to the previous state. And then we'll use those context variables to draw stuff. Okay, and this is perhaps the first place where we should start. So here you should modify the turtle's position by, I think there's some typo here, by accounting basically the length and the direction. So we can see that in the beginning the turtle moves to some position, but then we need to draw a line from that position to a new location. Also multiply the length of the line by these values or some other numbers. Set the corresponding line right and do the line 2. So basically we have a turtle position. This position, so what is it? It's a draw system call, that's this array, it's a 2-element array. So position 0, the x coordinate, should change by whatever the length currently is, and we multiply this with the x coordinate of the direction vector. So turtle direction x. Okay, and we do the same thing for y, so for the first element. Okay, this should make our turtle move, at least in one, based on this direction. So what else? We should do these length and thickness changes. So the idea is that if we don't do those, then like all of the branches have the same, both the height and the length basically. But we want here after each move, like the length and thickness to decrease a little. There will be a larger decrease when branching, and that will be done down there. But this is just some small decrease on the length. It will be, I mean, you can try out different values, you can try out without as well, see if this is good for you, but I will do it perhaps like this. Okay, and now we can set the corresponding line weight. So context line weight is whatever the turtle thickness is, so put in turtle line weight, and next we also have the line 2. So content context and context line 2 to the turtle's current position. So turtle position 0 and turtle position 1. And hopefully this should be able to draw us something. I'm also wondering if you're doing this line 2, should it be before updating it or after? Let's see what result we get. And we currently get this result. Now I'm not entirely sure what this result represents, so I'm going to take the rule and I'm going to make it just f for now. And I can see that one segment is make it bigger perhaps, this length. So what we have here is 2 of those f's are now being drawn sequentially. I can also do something like see what happens with this, and you can see that the line is getting smaller as we go along. So this is the idea why we decrease the length there. But branching decrease will be another one, another place. Okay, but we also have this rotation. So here we should actually rotate one of the segments. So for this we should implement something here. And while this is not the best way to do it either, so what this part does is that whenever it finds a plus sign, then it's going to loop from the first, it's gonna assume that the next symbol is, check that it's a bracket, and then it's going to loop until the ending bracket. And it's going to count like how many symbols you have there, and it's going to try to create a float out of those symbols between the brackets. But currently, because we haven't implemented this part, which you should do later, I'm gonna just write that angle is something like maybe 20 degrees. So I should now modify the turtle's direction based on the angle. And this is now something that we have a vector and we want to rotate it. And I hope you can think about it, how you should do this. So how do you rotate some vector that's given with x and y coordinates? So we have done such things before. So basically, I don't personally remember how to modify this, what's the actual formula, but what I do remember is that the rotation matrix was cosine of alpha, sine of alpha, minus sine of alpha, and again cosine of alpha, and x, y, right? So if I take this and apply it to my vector, then I find out that my rotated x should be cosine alpha times x minus sine alpha times x. My rotated y should be sine alpha times x plus cosine alpha times, those are of course y's, right? Okay, and this is something that I can try to do. So we have an angle, let's say it's 20, and one thing you should like be aware of here, that in the formula here you need x also in y calculation. So if you overwrite the x without storing this value somewhere, then your y calculation will be wrong, because you no longer have the original x, but you have something else that doesn't work. So we're gonna do it here. So let's say we have var x is now the turtle direction 0 times, and what did we have? We have the cosine of alpha, so math cosine of angle, and I'm gonna make these two radians over here. To this we add the turtle direction y, and actually we need to subtract, because here we have a minus sine of angle. The same thing for, sorry about that, so same thing for y, just that now we take a sine here and we add a cosine here. And in the end we can say that turtle direction 0 is now the new x, rotated x, and 1 is now the rotated y coordinate. Okay, and I'm gonna do basically the same thing down here as well, just that my angle is now minus 20. Okay, and let's see if I made any mistakes, and looks like I didn't. So the second branch is rotated by, well, currently a fixed value, but it's at least rotated. Now one thing you should be aware of, that is we have plus here. So plus says rotate left, and this doesn't seem left, it seems right, so we should actually rotate it the other way around. So be sure to do it correctly, because if someone tells you that I'm sending you this file has this big word in it, and whenever you encounter a plus, you should then rotate counterclockwise by the angle following the plus. When you encounter minus, then you should rotate clockwise with the symbol following the minus sign. So, by the angle following the minus sign. So in that sense, it pays to pay attention to details. Is this plus to one side or to the other side? Okay, and down here, this is the part where you have the branching. So you can see that when you have this square bracket, it starts a branch, and an ending square bracket ends the branch. So those save the current state and load the last state. For saving and loading, we're going to use this JSON stringify. So our turtle is basically just a JSON object here. And in order to save it, there is this JSON tree added with this base code, which allows you to create a string of a JSON object. And the string then has this save state, and you can push it to a stack without fear that it will change. So push the string to a stack, and when you encounter this symbol, then you pop or load the previous saved state from the stack and use JSON parse to recreate the JSON, the actual turtle JSON from that string. And then you also need to move the context back to the location that was done. And when saving, when you encounter this symbol, then you know that this will start the branch, so it branches off somewhere. Then at this point, you should also, after saving the current state, multiply the thickness by 0.707. So this is what this Mr. Leonardo guy as rumored to have found out. But this one you can probably manage. Now, one interesting question is when we have stochastic rules, so what happens? Currently we have one rule with probability 1, but I can create other rules here as well. So perhaps let's create 3 rules. Let's say that one turns to one side, another turns to another side, and maybe there's one that goes just straight, doesn't turn anywhere. And let's say that turning is like 20% chance, and this is also 20%, and then we have 60% that goes forward. You can try out different rules, your own probabilities, take the ones that are here, and so on. Okay, so if we see it now, then we still get only this one result, because the rewrite system takes the first value. And now this is again a question that you should be able to come up with an answer to. Basically, when you have, and maybe we can make some room here, when you have set of things, or maybe not a set of things, but you have like thing A, which has this one has some 20% possibility of being picked. I think B that has also 20% possibility of being picked, and I think C that has 60% possibility of being picked. So how to write the program that picks one of those based on the probability? I mean, you could create a random value, so you know those things sum up to 1. So let's do a dice roll, and I think it's I think they've write it like something like this, where you have from 0 to 1 range random value. So okay, but now what do you do with this random value? How, based on this dice roll of this random value, can you say which one was picked? And this is an interesting algorithm, in the sense that if you haven't encountered this problem before, then it might be interesting to come up with this solution. Basically, you can loop through the values here, and you can start summing the probabilities. You have this one random value already, so if you take A, and let's say we have a value, let's call it perhaps current R, or this big R perhaps. So you take A, it's 20% possibility, so you check is this R less than 20%. So if it's from 0 to 0.2, and sure, let's pick A, 20% chance, this corresponds to the correct result. But if it's not smaller than 20%, then we need to add, here we have 20%, we need to add B's probability, so 20%. Now we have 40% R. And now we check is our random value less than this. If it wasn't less than 20, but is less than 40, then it's between 20 and 40, meaning that you then had 20% chance of picking this B. And lastly, we have the 60, so we end up with our 40 plus 60, that's 100%, and most probably like this was now below this 1. So this is something you can think through and see that it actually gives you option of those 3 based on each of the probabilities. And in this task, you should implement exactly that. So for this, we have this running probability and probability. And let's see what the comments say. you should pick one of the matching rules right sides and assign it using the probability. Random gives you a random number from 0 to 1. And you might also need to account for, like, when you have for some reason specified 0.33, 33, 33 for 3 rules, but then roll a 0.991, then what happens? So we have some rules, and we also have a probability. So let's take the probability, let's assign a random value to it, and we also need this running probability, which is initially 0. And now we're going to go through the right hand matching rules. So for example, you can make it a bit better as well, but something like this, plus. And actually, maybe an interesting place to show that we can also do it like this. So x in this array. And now, if we want to access one rule which we want, so the first thing we want to do here is say that the running probability is now increased by the current rule's probability. So let's take the current rule at index x. So this might be confusing from other languages. In other languages, this x will be an element from this array, but in JavaScript it will be a key of an element in this array. So don't get confused. And what is the, so the probability is the probability keyword here. And so we add the probability to the running probability. And now we can check if our probability, the dice roll we had up here, was less than our current running probability. Then basically we want to break out of the loop, and we want to say that our value, the value we're going to work on down here, is now the value of the rule x. The value is the right hand side value of the rule. Okay, and this should work. If this for some reason this doesn't work, because of some floating point precision, we sometimes go over the running probability, doesn't ever reach the probability or something like that, then it just assigns the first value and it should be fine. Or you could assign the last value here, which probably is better, but shouldn't matter much. Okay, now if I refresh, I get some branches to the right, some branches to the left, and this FA should probably have FA perhaps. So yeah, so now we get this. And this is also a place where you might want to debug, is this thing really correct? So you can write something like, okay, we have 3 rules, so check 1, 2, 3, and so here we say that check x plus plus, and let's have something like, I wonder if it works. Currently it doesn't work because the iterating system only executes once, so we also need a loop here, then iterations. This is something you should do yourself. And now we have a larger result. Of course, those rules are a bit weird and so on. And the check says that we have 3 times the first rule, 1 times the second rule, and 6 times the last rule. Maybe if we put 1000 here, then what does the check say? 200, 200, and 500. So this is a bit more than 2 times the previous ones, and maybe this is that. So if I do it multiple times, so 200, 175, 600, so about 3 times larger now, and 3 times is what we would expect. Maybe if we have a higher number, then it's gonna take some time. And so 2000, 2000, 6000. So this is pretty much the probabilities that we had here. So this probably now works correctly. Okay, but this is all we're going to do in this video. So next you should be able to come up with some rules here. I'll take the ones from the task description. Don't forget to have this loop based on the iterations count. Maybe you don't want this here, depending on if you are debugging or not. This probability picking is an important algorithm. Here you should replace this A in the string with some random like degree. In the task it says degrees from 20 to 30, so that should be fine. Then return the result string, not the same rule back. And in the draw system, this part we did. Here you should get rid of that and check that is this -1 really correct here. So does it rotate to the right or to the left? So I don't know. Make sure this is correct. And here save the state to a stack as a string. Decrease the width by this value, and here load the state and reset the position. And this should be all that you need to do. Then you can put this thing in and get this kind of result. So feel free to be creative with this task and read the book if you want. It has cool pictures, lots of stuff in it, and I hope you have fun.